for this image.
No, not for this image. Disregard this image. We're
Okay.
trying to find this force. How would you solve for this force?
Oh, just multiply by A.
Yes, so it's just pressure times area.
Yeah.
Right? Now we're finished with solid mechanics. We move to fluid mechanics. You said what is pressure in this case?
That's going to be rho times G times the height.
Times the height, exactly. And now we introduce area, so that gives us force.
Oh, okay, gotcha.
So that's your equation right here.
Got it.
That's your
Okay.
first equation. Yeah, I know it has a bunch of terms like you see density, gravity, but I like to like derive it from solid mechanics first. That way you never forget this formula. You know pressure is equal to force over area. And what is pressure in fluid mechanics? It's just rho GH. And that's how we get this formula. So you know
Oh, and the
that
force
way
for fluids, right? Oh, I see.
you'll never forget this formula.
That's true. It's very helpful.
Yeah, so if we want to continue to expand this formula, like what's rho G?
Rho G will be specific weight.
Specific weight, exactly, yes. So it's gamma HA. That's the formula you want to memorize right here. It's just rho gamma HA. That's your force.
Got it.
Okay, so this is your first formula. That's how you calculate the magnitude of the force. Right? You now, for example, let's look at this one right here. And you want to calculate the pressure exerted from the water, this one, on this gate. You see the flat plane right here, this gate?
Yeah.
Okay, well, we know the magnitude. It's right there. It's gamma HA. That's your magnitude of the force. But now we want to know where it applies. Like, where should we put this force? Should be at the top, at the bottom, at the centroid of the gate? Where should we apply this force? Now we want to find the location of this force. And two simple formulas, right? These ones, I'm pretty sure you have to, maybe you just highlight them in the book or something. But here's the two formulas. CP, for this one, XCP. CP stands for center of pressure.
Okay.
Right? Remember,
That will be the point where the pressure is applying the system, in the whole system.
That's where you can. Well, let me go over CG first. What is CG?
Okay. CG.
In solid mechanics, remember? Yes, center of gravity. Exactly. And why is it useful? Why do we? Why are we interested in center of gravity? Remember?
Yeah, because that's where the forces will be applied on, either normal or like the way.
Yes, exactly. You can combine all the forces applied to the body on one single location, center of gravity. That's it.
Right.
Right? So for this one,
Okay.
same thing. For pressure, center of pressure, it's the same thing. It's the same meaning. But it's not located at the center of gravity. It's kind of off from the center of gravity. Right?
Oh,
so
I see.
XCP, here's the formula. Remember moment of inertia, this one, IXX?
Yeah. Yeah.
This one should be IXY, not IXX. Okay, here's the formula for XCP. That's the X coordinate of the center of pressure. Right?
Okay.
You have now YCP. We
Right.
have a X and Y, so we need YCP. and it's basically negative I xx sine theta over same thing, HCG times A. These are your three formulas that you need to know when you're dealing with hydrostatic forces. These are the three formulas you're going to use. Once the problem is telling you to calculate hydrostatic force on a flat surface, go to these three formulas.
Oh, okay, got it.
But I want to double check I have them correctly. Like, you have these in your notes. Can you double check if I
Yes, I
listed
do.
them correctly? Hopefully I did. Yes, looks like I did.
Oh, okay, yeah, he used what's it called? Rho? No. So he used pressure PCGA on the bottom.
Yeah. So
But it's the same thing, right?
it's the same thing. These three formulas, when you're dealing with gauge pressure, right? We're not dealing with any atmospheric pressure. This is just mainly for gauge pressure.
Oh, I see.
Right? This is only for gauge pressure. Because what is gamma H right here? Gamma H is the pressure at that location, right? At location H, but that's gauge pressure. That's not absolute pressure. And I think I confused some of you guys last session between what is gauge pressure and what is absolute. What's the difference between the two? And would you like to tell me, like, what's the difference between the two?
I was gonna ask you that to help me define the. Because I'm not really too sure about that.
Okay, so let's go back to this one. We have P absolute and we have P gauge.
Okay.
We have two different kinds of pressure. One is P absolute and one is P gauge. Right? So at sea level, imagine I'm standing at sea level and I'm holding a pressure gauge. I want to measure the pressure at that location. I'm holding a pressure gauge at sea level. The pressure gauge will read what? What's the reading on the pressure gauge?
118, right?
Pressure gauge doesn't measure absolute pressure. It measures gauge pressure.
Oh, so it wouldn't be 118 will be the absolute pressure.
Would be the absolute pressure, yes.
Oh. Okay.
And what about gauge pressure? I'm holding the pressure gauge in my hand and I'm looking at the reading. It's going to be what?
Oh, would that be without the G in our formula?
Without 1 atm, it's going to be 0. It's
so it would
basically
be 0.
It would be 0.
Oh.
Right? Okay, let me go to a different example. You want to measure the pressure in your car tire, right? You notice, like, you have a flat tire. You want to measure the pressure in your tire. So you stick in a pressure gauge, and the pressure gauge is telling you, oh yeah, you have a flat tire. You have 25 psi. What is that? What's this reading? Is it a gauge pressure or is it absolute pressure?
That's a gauge pressure.
Exactly. Right? That is a gauge pressure. Okay, and you want to take this 25 psi. You want to calculate absolute pressure in your tire.
You just add ambient pressure, right?
Yes, exactly.
To
perfect.
It. Yeah.
Yes. That's the only difference between the two. So if you want to write the formula, P absolute is basically P atmospheric, or like you said, ambient, plus P gauge. That's
Oh,
the
okay, so
formula.
that's absolute.
Yep. So that's how I remember the difference between P gauge and P absolute. If I want to go to the gas station and measure the pressure in my tire, I stick in a pressure gauge and it reads 36 psi. That's the gauge pressure, but that's not absolute pressure. I have to add 1 atm to this reading. That way I get the absolute pressure.
Alrighty. Okay, okay. That makes sense.
Right? Here's the formula for this one. So if we go back to this one right here, like you said, the professor is using PCG, not HCG,
Mm-hmm.
right? If you want to use PCG, that means we're calculating absolute pressure, not gauge pressure.
Oh, okay. And when would you use that instead of this, for example, in which situation? Because how would you know this is a gauge, even though you have, well, like you have kind of atmospheric pressure?
Mm-hmm. The problem, like with the problem, will tell you specifically to calculate. Like, let's see this problem. Like this problem is not mentioning anything about gauge pressure or absolute pressure.
Uh-huh.
Nothing is mentioned in the problem. Like I'm reading the problem statement and nothing is mentioned,
Mm-hmm.
right? So I always assume it's gauge pressure because really we're interested in gauge pressure all the time, right?
Right.
If someone comes up to you and asks you, what's the pressure in your tire? Are you really going to tell him, oh, 25, let's assume its gauge pressure is 25 psi, and you add 14 and you tell him, oh, 39 absolute pressure? He's going to be like,
Yeah.
why are you telling me absolute pressure? I'm interested in gauge pressure.
Got it.
Right. So we like to deal with gauge pressure all the time, unless the problem tells you I want to deal with absolute pressures.
Oh, okay. Sounds good.
Right? So these formulas are for gauge pressures.
Okay.
If you want to deal with absolute pressures, follow the formulas the professor gave you. You just replace this one with PCG.
Okay. Sounds good.
And I think that's it, right? Yeah, you just
Well, it was PCG, and then you will
and
multiply it by gamma.
by gamma, exactly.
Yeah.
Yes, you have a gamma there.
Yeah. Uh-huh.
But
Okay, got it.
hopefully for these problems we deal with gauge pressures really, because that's what we like to deal with, gauge pressures.
Yeah. Sounds good. Mm. Okay.
Okay, I think that's a good review. Any questions?
No.
Okay,
Perfect.
great. Okay, so let's leave these three formulas and maybe erase these ones and go over the problem. So the problem is telling us to calculate the mass of this cylinder, this one,
Okay.
M. We want to calculate the mass of this cylinder to hold this gate, right? I think
Mhm.
if H drops, yeah, the level of water, if it drops below 2.5, if it drops below 2.5, the gate will open. So basically we're trying to hold this gate.
Okay.
Okay, so how would you approach this problem, for example?
I will start off with a body diagram, forces.
Right, that's like 50% of the solution, really. It's just free body diagram. Good job, yeah.
Yeah.
Okay, so oh, you want to draw the free body diagram for which?
For the cylinder inside the liquid.
Okay, sure, we can do that. So here's, imagine this is the cylinder, and what are the forces acting on the cylinder?
Well, you have the weight
You have the weight,
and
exactly.
going down, and then you have tension going up,
You have tension, exactly.
and then you have the pressure pushing up the cylinder, correct?
Perfect. Yes. You have the, we call it FB or the buoyant force.
Okay.
Right? Exactly. This is really good. I think you aced your statics class.
Yeah.
Great. Okay. Okay.
And then also you will have the forces on the, what's it called? On the pin.
On the pin, or let's draw the free body diagram for the gate.
Okay.
Right.
Oh,
so
that's
imagine this is the gate. It's a flat plane.
good.
And you have, what are the forces acting on this one?
Well, you also have the weight for it, but we
Oh,
will ignore that, right?
great. Yeah, neglect weight. I think the problem tells you to neglect the friction at the pulley. Okay, but yeah, neglect weight. Let's neglect it.
Okay. So at the bottom you have the forces on perpendicular and vertical, the normal on the pin, right?
On the pin, yes. OI and OX.
Yeah, and then also on the top.
You have what?
Forces horizontal.
Where at the top though? You mean at the cable, right? Or at the tension cable?
At the tension cable, correct.
Yes. So right that way. T. And what else? So if you don't have water, this is the correct free body diagram, right? If imagine there is no water. Okay, but now we're in fluid mechanics. We're gonna put this gate in water. What do we have if we introduced water to the system?
Oh, the pressure on the.
Exactly.
So would that force will also be going up? No, right?
So the gate is flat, and you have water filled here. So the water is trying to do what to the gate? It's not trying to lift it because there is no water.
Push it.
Push it this way. Push it.
Okay.
Why? Because of the hydrostatic force. Right. So you have a force. We don't know the exact location of this force, so you can put it anywhere really, and call it FH. We're going to use these two equations to find the exact location of this force.
Oh, okay. So that's what we found first, and then we go to the forces, right? Like the X and Y.
Yes.
Oh, I see it. Makes sense.
Okay, good on that one.
Yes.
How would you calculate? So do you want me to solve like the entire problem, or should I just give you some hints how to solve it and then jump straight to curved beams, or not curved beams, that's solid mechanics, curved surfaces?
Well, you have to use a formula for the moment, right?
Yes.
Moment.
Yes. You need the okay. So you said you need the formula for the moment to find.
And also we'll need the area, right, of the
gate.
Yes.
And this one, yes, great that you reminded me. So notice right here it says 4, right?
Right.
It says 4, so that's the height, and the width is given in the problem 2 meter.
Oh, okay. So times 2, so 8. 8.
So 8.
Oh, okay. And what formula would you use for the moment? Because I know for example, a rectangular shape will be different, right? Than
for moment, you can calculate the moment at this location. Oh, that way you don't have to calculate any reaction forces, because if you want to calculate moment at this location, these two will cancel. Right?
Right.
So
okay. Okay. I meant for like the XCP and the YCP.
Oh, the XCP and YCP. Okay, so let's go over these ones. We notice we have IXY.
Yes.
Right? And for IXY, I think I have the formula somewhere for these two. It's in the book, yeah. If you wanna, let me share my screen.
Okay.
Can you see my screen now?
Yes.
Okay, so you see right here, I for a rectangular surface.
Oh, okay. So those are given then.
Yeah.
Those formulas. You don't have to derive them yourself, right?
No. Do not derive
Oh, okay.
anything. Yep. It's just that these are constants, really.
Oh, okay, okay. Sounds good. Because I was like, do you have to deriving yourself for every shape?
Yeah.
Okay.
No, it's just too much.
Yeah. Oh, okay. Awesome. So you would just plug in, and then from there you would do the moment on the beam to find um like the forces, but you will need tension first, right?
You would need tension, but we
Yeah.
know how to calculate tension. You drew the free body diagram.
Yeah. And that force for buoyancy, what would be the
There's a formula. If I know how to share my screen on my iPad, hold on. Oh, I think I can show it. If you go to section 2.8, which is
uh-huh.
buoyancy, here's the formula for buoyancy.
Mm. Oh, I see. And that the displacement would be 2.5.
Displaced, if we go back to the problem, uh, it's just starting to share my screen on my iPad.
Okay.
So let me zoom in. It would be h minus 1, right? Because this is 1 and this
Uh-huh.
is h. So if you want to find the volume, right? This volume, you see this little piece hanging out of the water
Where?
right here, this one,
Uh-huh.
right? It's not fully submerged into water. Just little pieces hanging out.
Oh, okay.
So buoyancy is always just the volume of the solid in the water. Anything above the water, you don't calculate the volume for that,
Oh, okay, okay.
right? So if you want to calculate the volume for this cylinder, this height right here, this height will be h minus 1.
Oh, okay. That one.
And
Gotcha.
you multiply this height times the area, the cross-sectional area, you get volume.
Oh, okay. Yeah, makes sense. Just you gotta just have all those formulas on what to use. It's a lot of formulas. Could you just solve it real quick?
Solve this
See,
problem?
yes, if you're able.
Okay, let's solve this one. And hopefully, because I have another session on Sunday, if that works
Uh-huh.
for you too, if you want to see curved surfaces on Sunday, that works for
Yeah,
me.
yeah, that'd be awesome. I'll try to do it as many as I can. It really
Okay.
helps me. It really helps.
Okay. So let's see right here. Yeah, let's calculate this force FH, right? Because we have a formula for it. It's just gamma HA,
Yeah.
right? So let's calculate this FH. The hydrostatic force is gamma HA. And let's leave it like that, gamma, right?
Yeah.
And then over here
8, right?
for H, you mean?
Oh, for 8. Oh, no, no. For A, for the area was 8, but for H, we just leave it as H, right?
No, so for this H, remember I wrote right here, it's HCG. What is HCG in these two formulas?
Um, the height of the center of gravity.
Yes, the height of the center of gravity. That's how you calculate. I know we're calculating the location of center of pressure, but the location of center of pressure depends on the height of the center of gravity.
Okay.
Okay, so for this formula, gamma HA, it's gamma HCGA, like that.
Oh.
I just forgot to write CG down there.
Mm.
Right, so how would you calculate the force? You use this formula, gamma HCGA.
Okay. Okay.
Right, so I should write down HCG right here. And what's the height of the center of gravity in this problem?
The height of the center of gravity. We're trying to find it, all right?
Yes, we're trying to find it. So if you look at this problem, let me zoom in and try to make it clear here. So the entire height of the gate is 4, but only H is submerged into water. Right?
I'm sorry, say that one more time. I didn't hear
So
you.
the entire height of the gate is 4 meters.
Right.
And only H is submerged into water.
Right.
Is that correct? It's not the entire height, it's just H of that gate. As you see in the picture.
Mm-hmm.
Right, so if you want to calculate, if you want to follow the formula and calculate the force right here, gamma, this one, gamma HCGA.
Yeah.
What would be your HCG in this case, in terms of H? Because we don't know what.
4 minus H. Wait, is it 4?
Let me zoom in. So you see this one right here, H. This one, H.
Yeah, that's the height of the entire, like the water, right?
The water. That's the height of the water. Now you want to find HCG, the centroid of this height.
Oh, okay, so H over 2.
Yes, exactly. Yes, that's the most confusing part about this problem. It's not the entire gate. It's just the water, the height of the water over 2.
Okay.
Because right now the HCG will be somewhere. If this is the entire height is H, this is HCG in the middle of this water level.
Okay.
Okay.
But it's not, that's CG, right? I mean CH. I mean HCG. But for example, the XCG and the YCG, what is that point again? If we use our formulas, these two formulas.
So HCG will be the same. It's H over 2.
Okay. Okay. So, but this XCP and YCP, that's the coordinates for the entire beam, then the entire thing of the gate.
No, just for this water level.
When you find XCP and YCP, what does that find?
It finds the coordinates of the center of pressure. Remember right here, we found this is HCG right here. This one. This is HCG. What's the coordinates of this one?
You said you did that?
H over 2. Yeah, right. If you have a rectangle, imagine this beam is showing you 2D, but this beam is actually 3D. It's just it has a height and a width. So if you're standing right here and looking at the gate. Look straight to the gate right here. What do you see? You see a rectangle in front of you.
Right.
What's the center of gravity of this rectangle? It's basically in the middle for rectangles. right? So this XCG and YCG will be what? For
for the rectangle will be the middle point then, like
the middle point, exactly. And for Y, it will be the middle point, and for X, it will be same middle point, so 2.5,
mm-hmm.
2.5 over 2, or 2, excuse me, it was 2 meter wide.
Okay. Makes sense. It's more clear now.
Okay, so we only care about the like the section of the gate that is submerged into water. This 4 meter is kind of misleading because some of it is not even submerged into water, like this one right here. This section is not submerged. We only deal with submerged surfaces.
Okay. Sounds good. Makes sense.
Okay, so if you want to solve this one for FH, gamma, and HCG, we know it's H over 2. And what is A in this case?
2 times 4.
Oh, we're only dealing with the part of the gate that is submerged into water.
So that would be H times 2.
Exactly. Yes. I think now you get it. Yes.
I got it.
Yes. H times 2.
Mm-hmm.
Right. The entire. It's good to label these areas. So I should write maybe A submerged. It's not the area of the entire gate. It's only the area of the submerged a part of the gate.
Oh, okay, yeah, it is confusing. Okay, got you. All right.
Okay. So here's your, in terms of H, you can cancel the 2 and you'll get what? Gamma H squared.
Mm-hmm.
Okay, and now we want to find what's next? What do you want to find next?
We can go for the tension.
Okay, let's go for the tension. So tension, yeah, you can tell me what to write.
Yeah, it just force with tension times the height of the beam times force.
So one more time.
So it's looking for the moment, right?
You want to write the moment equation?
Mm-hmm.
Okay.
Like
so
beam.
It's force times distance, so T
times 4.
T times 4. Okay.
And then since you have you can add the 2 moments now.
So we want to calculate the moment at this location. So this is equal to moment at point O. So we can cancel these 2.
Right.
Take the moment at this location. So you have what? You have, if you go from the pin, you have 4 times T, right?
Right.
And you have AFH times, we don't know. This is still, we need to calculate YCP.
Mm-hmm.
So let's leave it as
it should be one should be minus, one should be plus, right?
Yeah, one should be minus. Let's go with T minus. Clockwise is minus.
Yeah.
So this is minus and this is plus. FH times YCP, because we didn't calculate YCP. Okay. So let's calculate YCP then. It's just following the formula negative I x times sine theta over HCG times A, right?
Yeah.
That's the formula. So what is sine theta in this case?
It'd just be 0, right?
It will be sine theta. If sine theta is 0, YCP will be 0.
1. Oh, wait.
So
Sine theta.
well, what's the angle
Oh,
for
yeah.
this gate? It's vertical. So if you have a vertical gate, what's the angle?
Oh, 90.
90, exactly. So sine of 90 degrees is
1.
1. Okay. And what is area in this case, we said?
It's 8. Well, it's in this case, it's just going to be from the submerged part also, right?
It's going to be for the submerged part.
Okay, so it'll be 2 times H.
2 times H. And what is HCG in this case?
We said it was H over 2.
H over 2. And negative IXX, if you go back to the book, there is a formula for moment of inertia, right?
Okay. So you show me that BL to the Q over 12 or something?
Yeah.
Okay.
But I want to see, like, the book is telling you BL cubed over 12, right? But what is it of the entire gate or only the submerged part of the gate?
Oh, only the submerged part. Right? Wait, the area. Yeah, that just the submerged part.
Okay. So let's go with the submerged part, which is B. What is B then for the submerged part? The width?
It's 2.
It's 2 given in the problem, right? And what is what's next? L cubed, the height cubed.
The height also is the H cubed.
H cubed.
Over 12.
Okay, over 12. Times sine of 90 is 1. And you calculate all this. What do you get if you do? So these two will cancel.
Will be H over 6.
Let's see, H cubed. Yeah, let me 2 over 12. So this is H. Yeah, one. Yeah, should be.
Okay.
But in this one, like, I solved this problem, I got H over 3. Where did I get that from? Hold on, let me double check. Let's review. Did we do it correctly? YCP.
Or does it have to be 4 for the whole entire length of the beam? Because that will make it 3, but I'm not sure.
4, you mean for the area, or where?
For the L in the formula for the moment on the X, the IXX.
Okay.
For L we put 2, but should it be 4 of the entire thing? No, right?
No, the width is 2, right? I think,
Oh yeah,
yeah, and
the
the
width.
problem, it's 2 meter wide.
Oh yeah, it's right. The base. Yeah. Wait. Height.
Meter, yes. Okay, so h over 3. I mean, I kind of know that it's h over 3 because I know the center of gravity, or the center of gravity is going to be in the middle, and that one is going to be point kind of what? Yeah, it's below it. Yeah, that's why I know I think my solution here is right. It's actually h over 3,
Mhm.
but I'm trying to solve it here. Did we forget? I'm pretty sure we forgot something. That's why it's h over 3.
I wonder why. Um,
Yeah, do you have any idea?
I'm trying to look for
hopefully,
it.
hopefully I didn't confuse you, but I can. Do you have GroupMe? Do you have GroupMe on your phone, or?
I have Discord.
Oh, you have Discord. Okay.
Yeah.
Uh, would you mind posting it in chat, and so
Yeah.
I can add you, and we'll probably like solve it one more time and
Okay.
make it clear, and maybe send it to Discord.
Okay.
I wanted to set up a GroupMe last session, but I forgot really.
Okay. Yeah, we can do that. That would be pretty cool to whatever other people missed. They can just go there and get.
Yeah, sure. I can add you on
Uh,
Discord.
okay. Is my thing? But I don't know where we could have done it wrong though.
Yeah, I'm thinking right now. We'll see. Probably work on it today and post like the solution, and you can ask me.
Okay. Um, it's just my username, right? How do
On
I add
Discord,
you?
uh, let me see.
I sent you like number, but I'm not sure.
Number 7821. Is that it?
Yes.
Okay, so let me see if I can do something. Okay, you can add me. Let's see if it works. If you can add me, that's my username. Should probably change it.
I'm at you right now. See if you can get. Are you on it right now?
Yes, yes.
This it doesn't. It doesn't work.
It doesn't work?
Mm-mm. What's your
Okay.
4-digit tag?
That's what I'm trying to find.
It should be on like where you see your name on the bottom part of Discord.
Oh, it's okay, okay. I think I
Yeah.
found it. So try this one and see if it works.
Okay. Okay, I just sent it.
Oh yeah. Okay, got it. Okay.
Awesome.
So I can text you and see, and obviously you can just let me know, like if you want to meet during day or something. I can meet.
Oh,
Maybe
cool.
if you have a question or something.
Oh, awesome. Thank you so
Okay.
much for your
And
help. I
oh,
really
no
appreciate
problem.
it.
Oh, no problem. No problem. Hopefully I didn't confuse you with this one.
No,
It's
you
just
really help me a lot every time. I'm not even lying.
all right. Okay.
Yeah, well, just let me know if you find like that where we messed up, and that'd be awesome.
Yeah, definitely. Yep.
Thank you so much.
All right.
All right,
Thank
have
you.
a good one.
You too.
Bye.
Bye.